Okay, what is the relationship between the sine of A and the cosine of B? That's where we're gonna pick back up here. For example, if this is A, and this is B, and this is C, then opposite of here is A, but it's adjacent to B. Opposite from here is B, but it's adjacent to A, and this is the hypotenuse C. So what is the relationship between the sine of A and the cosine of B? They're equal to each other, aren't they? That's always true. Because opposite over hypotenuse and adjacent over hypotenuse for B happen to be the same thing. So the answer here is B. That's true. Okay. The cosine of angle A is what ratio? Adjacent over hypotenuse, hypotenuse over adjacent, opposite over adjacent, opposite over hypotenuse. Cosine.
A.
Adjacent over hypotenuse. That's true. Define the sine of an angle using words opposite, adjacent, and hypotenuse. Define sine.
Opposite over hypotenuse.
Opposite over hypotenuse. We're just still in that mode where we're trying to get that in our head, okay? Define the tangent of angle A in the same, using the same words. Tangent.
Opposite over adjacent.
Opposite over adjacent. Define the cosine. Oh no, what is the reciprocal function of the cosine of A? Now the reciprocal functions were secant, cosecant, and cotangent. Which one goes with cosine? Remember I told you the C's and the S's don't go together?
Secant.
So it would be secant. Secant of angle A, which is abbreviated this way. So secant would be to find the opposite of cosine. If cosine is adjacent over hypotenuse, then secant would be hypotenuse over adjacent. You would just flip or find the reciprocal of cosine. So what is the reciprocal function of sine?
Cosecant.
Cosecant. That's spelled this way. It is abbreviated this way. And if sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite. So what is the reciprocal function of tangent? Sounds just like it. What do you say? Y'all remember how you say it? It's pronounced cotangent, and it's abbreviated this way. So if tangent is opposite over adjacent, then cotangent is adjacent over opposite. So we need to know those, okay? We need to know all those definitions of what everything means. Remember the shortcut for the three basic trig functions, sine, cosine, and tangent, is some old hippie caught another hippie tripping on acid. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. A lot of teachers call that Sakatoa. If you're not a good speller though, you might want to remember about the hippie. Some old hippie caught another hippie tripping on acid. That might help if you're not a good speller. Sakatoa. What is the acronym shortcut to help us remember the 6 trig functions? I just told you. Sakatoa. Some old hippie caught another hippie tripping on us. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Alright, get out your calculator, make sure that it's in degree mode. So that means on the screen somewhere there will be a D or a DEG. And round these answers to the nearest thousand. Round those answers to the nearest thousand. Double check the first three, are we good? Alright, cosecant goes with what? It is the reciprocal of sine. So what you will do on your calculator is you will find the sine of 32, get an answer, and then use your reciprocal key, which either looks like this or this, and it will flip it for you, okay? So I'm going to find the sine of 32, and then hit my reciprocal key, and hit equals. And on that one I get 1.887. See if you agree with me. What you do not want to do, listen carefully, you don't want to use your second button or your, what do y'all know? Does everybody pretty much have a second button to get the things that are written above the button? You don't want to use these. These buttons are used only to find the measure of a missing angle. That's when that use those. I'd make note of that. That's the only time that you use those buttons is when you're, and they're actually not buttons, they're just above the buttons, you know, like right up here. You don't use those unless I say, what's the measure of that angle? Then you would have to use these keys up above sine, cosine, and tangent. So for the reciprocal functions, you're going to stick with the reciprocal button, which is this. So for cotangent, we'll find the tangent of 74 degrees, get an answer, and then use our reciprocal button, whichever one of those is on your calculator, I'm not sure. So tangent of 74, hit equals, find the reciprocal, make sure you hit equals first. And so what will we use for secant? Cosine. So we'll find the cosine of 83. We'll hit equals, and then we'll use our reciprocal key, whichever one of those we have, okay? So cosine of 83, hit equals, find the reciprocal, round to the nearest thousand. Using your own calculator, do you have luck finding those answers? Does anybody need help with the calculator? That's all those problems are for, is to know that you can do that. Okay. Now here we have a geometry problem, really. Use trig with. We have a right triangle. And when we have a right triangle, we have a right angle right here. We can use sine, cosine, and tangent. Now we're to find the measure of angle P, and we don't know what P is. So remember I told you just a minute ago that in order to find angles, that's when we use these right up above the sine and the cosine and the tangent. Alright, so we have to decide which one of them we're going to use. With respect to angle P, is 9 opposite, adjacent, or hypotenuse? With respect to angle P, 9 is? Adjacent. That's right. With respect to angle P, is 5 opposite, adjacent, or hypotenuse? What trig function has opposite and adjacent? Tangent. That's how we know which trig function to use. We're going to use tangent because we have those two sides. We have opposite and we have adjacent. So we would set that up to say that the tangent of angle P is equal to opposite over adjacent. Now, just like when we add, we subtract to undo. When we multiply, we divide to undo. When we square root to undo. When we have a tangent, we need to use the inverse tangent of 5/9 to give us the measure of angle P. We're going to use the inverse tangent of 5/9 to give us the measure of angle P. And when we find angles, we're going to round to the nearest whole number. Okay? So on my calculator, I'm going to show you how this works. Maybe. Okay, there it is. I'm going to hit second tan. And then the parentheses, you can do 5 fraction button 9 or 5 divided by 9 and hit equals. So what would you say, 29 degrees? That's how it looks on the calculator. So 29 degrees. That is the only time you use those on the calculator. That does not mean, these guys don't mean secant, cosecant, and cotangent. These mean I'm finding the measure of an angle. Need help on calculator? Okay, too bad. Alright. Now we're going to solve the triangle. What does that mean? That means we have 6 angles and 6 sides. No, we don't. We have 3 angles and 3 sides. We have 6 parts, and we're going to find everything that's missing. Alright, I have a 90-degree angle and a 41-degree angle. Obviously, if this is my right angle, these are two I have to be acute. What is the sum of all the angles of a triangle? Always 180. And so please use your calculator if you need to and tell me the measure of angle B.
49.
Alright, see, these two have to add up to be 90. What do you call that? Starts with a C. If they have to add it to be 90. Complementary? Okay. And so 41 and 49, does that make 90? Okay. Now we've got to find little a and little c. We've got 3 parts to find. We've already found one. Alright, so there's the first part of my answer. Alright, I'm just going to decide that I'm going to find little a next. With respect to the angle I am given, what is A? Opposite, adjacent, or hypotenuse? Opposite. And 7.4, the only side I am given is adjacent. So with respect to the 41-degree angle, opposite and adjacent tell me what trig function? Opposite and adjacent. Tangent. So I will set that up like this. The tangent of 41 degrees is equal to opposite over adjacent. I have a proportion. How do I solve a proportion? I cross multiply. And so on my calculator, A is equal to 7.4 multiplied by the tangent of 41 degrees. Alright, type that in. See if you can do that on your calculator. 7.4 times the tangent of 41. And since we're finding a side length, we're going to round to the nearest tenth. With angles, we're going to round to the nearest whole number, okay? So I have 6.4. Do you agree? Okay. So there's 2 parts. Now we have to find C, and C is the hypotenuse. All right, time out. Question. With respect to the only angle I'm given, this is still the adjacent side, and I'm looking for the hypotenuse. So adjacent and hypotenuse tells me what trig function? Adjacent, and think about SOHCAHTOA. Cosine. Right. So we would say the cosine of 41 is equal to adjacent over hypotenuse. I have a proportion. I can cross multiply. I would have C times the cosine of 41, which is a number, is equal to 7.4. So here's the shortcut for my calculator. If the variable's on the bottom, you take the number on top and divide by this, okay? If the variable's on the bottom, you take the number on top of it and divide it by this.
Wait, how'd you get cosine there?
Good question. I got cosine because with respect to the only angle I'm given, this is the adjacent side, and I'm looking for the hypotenuse, and adjacent over hypotenuse is cosine. SOHCAHTOA. C-A-H, okay? Alright, so say 7.4 divided by the cosine of 41 equals, I got 9.8.
Can you do Pythagorean here?
You could, but we're learning Trig, so I want us to use Trig, okay? That's a good observation. It's true. Alright, see if you can do that on your calculator. 7.4 divided by the cosine of 41. No problem? Okay. So why did I not use sine? I had to go with the information I had. When I'm looking for A, it was opposite, this was adjacent. That tells me opposite, adjacent tells me tangent. When I'm looking for C, this is still adjacent. Adjacent and hypotenuse tells me I've got to use what? Cosine. So it depends on what you have, and that dictates the function that you're going to have to use. I think usually that's the hardest part to get across in my class, okay? Usually. All right, so we're going to solve the triangle, and we need to find the measure of angle K. We need to find little k, and we need to find little m. Okay? See if you can find the measure of angle K. What'd you get?
42.
42. Alright? Now, I'm given this angle, and in case that I mis-subtracted and got the wrong thing here, if I tried to use this 42-degree angle to find everything else and it was wrong, what would that cause to happen in the whole problem? Everything would be wrong. So I always try to use the angle I was given, which is the 48 degrees. With respect to the 48 degrees, what side am I given? 10.5. What is it? Opposite. Okay? Now I'm going to find little k first, and with respect to the 48-degree angle, little k is right beside it. If in case you're confused about adjacent, remember this. I've got two acute angles. Okay? An acute angle is made up by the hypotenuse and its adjacent side. Well, everybody can find the hypotenuse, right? So the other side's always adjacent. So if this is adjacent and this is opposite, what trig function is that? Tangent. So the tangent of 48 degrees is equal to opposite over adjacent. Alright, we would cross multiply. What was the shortcut I told you a minute ago? If the variable's on the bottom, you take the number on the top of it and divide by this number over here. Tangent of 48 is a number, alright? We're going to round these to the nearest 10. Does anybody agree with my answer? Okay. I'm going to let you out on your own just a little bit. I want you to find M. I'm going to give you time to find M. Alright, so to find the last side, we would do the sine of 48 is equal to opposite over hypotenuse. So on my calculator, the shortcut, we'd say 10.5 divided by the sine of 48 and get 14.1. Does anybody agree with that? Yes, good. Very good. Alright, I want you to find the measure of angle S. I want you to find little s and little r. There you go. You can bring your paper if you need to.
It was easier when you just gave me the ball and I worked the cut.
I won't always be able to do that.
That's the problem. See how you worked it out.
Right, so to find R with respect to the angle, it is opposite, and 9.6 is the hypotenuse, so opposite over hypotenuse would be the sine of 37 degrees is equal to R over 9.6. And then just cross multiply those. You guys get 5.8 right to the nearest tenth. Alright. Anybody have a question? Y'all are either sitting there silently, not understanding, or this is easy, you got it. We can move on. Question? Alright. How is this problem different?
Given two sides.
Two sides and only one right angle. We don't have an acute angle, right? Okay. I need one of those. We're gonna have to have an acute angle, so we're gonna have to find one of them, and then we can subtract from 90 and find the other. So let's say I'm gonna find L. Okay. Now, how do you find the measure of an angle using your calculator? We made a note of it. We use those little inverse buttons right up above here. Okay. So with respect to angle L, I've got two sides. 8.4 is opposite, and 9.6 is the hypotenuse. So what trig function uses opposite and hypotenuse? Sine. Alright, so the sine of L is equal to opposite over hypotenuse. In order to find the measure of angle L, I would need to do the inverse sine of 8.4 over 9.6. And then we're going to round to the nearest whole number, alright? So on my calculator, I would do second sine of 8.4 divided by 9.6. And I get 61 degrees. Am I right? Can you do that on your calculator and get the same answer I did? Yes? Y'all agree? Nobody's even giving me a head shake. Alright, good. Alright, now we can subtract that from 90 very easily and find K. But tell me, if I'd chosen to do K first, what trig function would we use? I would have adjacent. With respect to K, this is adjacent and that's hypotenuse. So if I were going to do K, I would say, alright, well then the cosine of K is equal to adjacent over hypotenuse. To find the measure of angle K, I would need to find the inverse cosine. If I subtract from 90, what am I going to get? 29. See if you get 29 doing this. We're rounding this 29 degrees. Agreed? Well, I'm not going to have much choice but to use an angle that I found to find the only other missing part here. Let's say that I decided to use the 61 degrees. If I decided to use the 61 degrees, I would be finding the adjacent side. So I could do opposite over adjacent and use tangent. Or I could do adjacent over hypotenuse and use cosine. Or, let's say I'm looking at the 29 degrees, and this is now opposite, so I could do opposite over hypotenuse and do what? Are y'all listening? Opposite over hypotenuse, I would use sine. Or I could do opposite, I could do opposite and adjacent and do tangent. I've got options. We can do it any one of those four ways, okay? I'll just pick one. I'll do the 61 degrees here. I'll be looking with respect to that. And I think I'll say that the cosine of 61 degrees is equal to adjacent over hypotenuse. And you can do it either of the other three if you want to. But we'll cross multiply. And we'll round, since we're looking for the length of a side here, we'll round to the nearest tenth. See if you agree with me. You can do right triangle trig. That's all there is to it. If you were given two sides, you can find two angles in the lost side. If you were given one angle in one side, you can find the lost sides and the lost angle. You can do whatever you have to do, okay? But you are required to be given three parts to find the other three. All right, do that whole thing. Find the measure of angle R using trig. Find the measure of angle S using trig, and then find little t, and we'll do those for dollars. Second tan, which would be inverse tan, or 3.8 over 6.8. You added, you added 29 and 9. I'm sorry, subtracted from 8. Yeah.
That's what I did.
Yeah. been subtracted from 90, the acute angle, but you can do the whole thing from 180, yeah, sorry. Now, to find T, you could use cosine or you could use sine. You couldn't use tangent. Tangent has nothing to do with the hypotenuse. So you could do like she did, the cosine of 29 degrees, which is angle R, is equal to 6.8 over T. You could do the sine of 29. You could do the sine or cosine of 61. But is this 78? What, 7.8? 7.8. Do you guys agree with 7.8? Okay. So can you guys do right triangle trig? Okay.
How'd you do the sine? Can you do the sine?
Of 29?
Yep.
You do the sine of 29 degrees is equal to, this is my 29, is equal to 3.8 over T, and so you'd say 3.8 divided by the sine of 29. Is that what you did?
No, I times the wax.
Oh. Okay, good deal. All right, let's talk about angles of elevation and angles of depression. This is a very weak, artistic attempt at angles of depression, angles of elevation. All right, this is sort of pitiful. Here's a jumper up here on the top of the building. And here's his friend, and he's hollering, no, you know, and then he's very sad. And so if they're looking eye to eye to each other, which looks like they're looking eye to foot, the way I have it drawn, this is the line of sight, okay? Now you notice a right triangle has been formed here because the building, hopefully, is at a 90-degree angle with the ground. If not, it's like the Leaning Tower of Pisa, you know, so you hope you got it right. It's square. If you ever build anything, the person who's building say, we're going to make this square. What does that mean? We're going to make it 9 degrees, okay? All right, so here's my right triangle, and here is my angle of elevation from whatever the horizontal line is here, whether it's the ground or whatever. Looking up to the person is the angle of elevation. Looking down the line of sight, and this horizontal is parallel with the ground or with our horizontal line down here, then this is the angle of depression. Notice the angle of depression is outside the triangle, unless I dropped an altitude right here and formed me another right triangle. Thinking back to geometry, if this line is parallel to this line, and this is a transversal, what's the relationship between the angle of elevation and the angle of depression? They're alternate interior angles, and they're congruent to each other, aren't they? All right. So, thinking about angles of elevation and angles of depression. All right, we're going to look at an application problem here, and you bear with me because this is a little challenging. But look on page 828, and you see my least favorite animal of all the birds here. It's puffins. You may think birds are very beautiful. I think they look like rats with wings. Yes. 828. An ornithologist, one who studies birds, is taking pictures of puffins on the edge of a cliff. That's two things you will not catch me doing. On the edge of a cliff, taking pictures of birds. But, you know, anyway. To find the height of the puffins above the water, she measures a 28-degree angle of elevation of her line of sight to the puffins. So here the puffins are up here, she's here. Here's her angle of elevation, 28 degrees. If her position is about 15 feet above the water, so now imagine down here is the water, and she's about 15 feet above there. We are to find above the water and 40 feet from the cliff. All right, she's 40. Here's the cliff. Here's the puffins up on the cliff. She's 40 feet out from there. We are to find how high above the water are these puffins. All right, so here's the puffins. Here's the water down here. We know 15 feet, but we don't know this. if we could find this using right triangle trig, and we added it to 15, would we find how high above the cliff that they are? Alright, so I have a 28-degree angle of elevation. I have a right triangle. Why? Because anytime you're judging height, you guys learned in geometry that that's an altitude to find the height. And it forms a 90-degree angle here with the ground. And so if this side, which by the way is adjacent to my 28-degree angle, here's adjacent, and I'm looking for this side, which is what? With respect to the 28-degree angle, it is opposite. If I have opposite and adjacent, I would use tangent. Alright, so the tangent of 28 degrees is equal to opposite over adjacent. Alright, so we're going to round this answer to the nearest, let's see, whole number maybe. Let's see what they did. Actually, they did the nearest tenth when they did it. So we'll say 40 times the tangent of 28. So they have 21.3 feet. And then for some reason they give the distance from B to E, which is the height the puffins are above the water. They round that to 21 and 15 to say, well, they're approximately 36 feet above the water. Using right triangle trig, okay?
Wait, how did you get that?
There was 21, approximately 21 here,
Okay,
and
I see.
15 was already there.
My bad.
So they just added them together. So it's kind of like a right triangle sitting on top of a rectangle. All right, this is, looking back in my textbook here. This is what we found. All right, suppose you're watching the Macy's Day Parade. Get rid of, okay, get rid of my background. Suppose you're watching the Macy's Day Thanksgiving Parade and you notice that one of the handling lines forms a right triangle with the ground. You estimate the angle of elevation looking up to the balloon to be 60 degrees and the handlers to be about 35 feet away from each other. Find the altitude of the bottom of the balloon to the nearest foot. So we're finding the altitude, which as you know from geometry means that we're finding the height. So what trig function would we use with opposite and adjacent again? Sounds like we've done this a lot today. Alright, so we would say the tangent of 60 is equal to opposite over adjacent. So to the nearest foot, what's the altitude of the balloon? To the nearest foot about 61 feet, right? An observer on the top of a 60-foot tall lighthouse sees a boat in distress at a 5-degree angle of depression. 5-degree angle of depression. How far is the boat from the base of the lighthouse? How far out here? Alright, so this is a 60-foot tall building. The observer is here. They're looking down the line of sight to this boat here. The angle of depression is the same here as the angle of elevation. So if you're finding x, set up using trig to find x.
None to the nearest.
Yeah, just to the nearest foot. 26 feet. You would say 60 divided by the tangent of 5. That's the shortcut. We still having a good look? Still know what we're doing? A square has a diagonal of 20 feet. Here's my square. It has a diagonal of 20 feet. What is the area of this square? How do you find the area of a square? Area is equal to side squared, right? Length times width. And in a square, what are the characteristics? They have the same side length all the way around. All right, so this is 20. And we also know we have a right angle. If you'll remember, a square is also a rectangle. It's a rhombus and a rectangle. So it has equal side lengths and it has right angle here. And so we need to know the length of the side. Okay. We also know that the diagonals of a square are angle bisectors. And so that's 45. Do you guys remember the 45-45 right triangle side relationships? So what would we divide 20 by? The square root of 2. Remember how 45-45 that these are the lengths and the hypotenuse is the square root of 2 times the side length. And so if you're going back to geometry, you would divide that by square root of 2. Hey, I can't have a radical in the denominator, so I rationalize. Square root of 4 is 2. I reduce, and so this would be what? 10 square roots of 2. If I forgot my geometry, which I think some of us may have, then using either sine or cosine. Why can I not use tangent? What is this? With respect to this, what is this? The hypotenuse. And so I can't use tangent. Tangent has nothing to do with the hypotenuse. So I would say, all right, the sine of 45 is equal to whatever my side, the opposite side there, divided by 20, and I would get a decimal approximation. Would you see if it's the same thing as 10 square roots of 2? So I would have 20 times